That's fancy. Hello. Oh, that works. Cool.
Thank you, Wayfair, for hosting us and also presenting about their usage of Presto. Before we dive into the specific use case of Wayfair, we will have Matt from Starburst introduce Presto briefly and then describe our recent integration with Kubernetes, which will allow to run Presto everywhere. So with that, Matt.
Thanks for the introduction. Great. Yeah, so before Wayfair talks about their use of Presto, I thought it'd be good to kind of give a high-level overview of what Presto is. I understand some of you probably have used Presto before, but in order to level set, let's start from scratch and start from the beginning and kind of explain the basis of Presto. I think that will help with the later presentation. In addition to that, I'll talk about the Kubernetes integration we did, as well as briefly what Kubernetes is. So my name is Matt Fuller. I am a co-founder and VP of engineering at Starburst, the Presto company, and I will talk about Presto. So briefly about Starburst, we were founded in 2017 by many of the largest committers to the open source Presto project. We've been working on it since 2015, so before we had founded Starburst, we've been working at Teradata, working on Presto, contributing it there. Our team consists of former Teradata, Vertica, Hadapt, Netezza, and Ab Initio employees. We've been working in the big data space for quite some time with a lot of background and experience. Starburst itself, we offer an enterprise Presto offering in pretty much any environment you'd want to run Presto, whether it's AWS or Azure, GCP, on-premises, and recently on Kubernetes as well. We're headquartered in Boston and have customers globally. So high level, let's talk about what Presto is. So Presto is a community-driven open source project. It was originally developed at Facebook, and it's a distributed query engine. So it's not a database, but it's a query engine that takes a SQL query and processes the data. And we'll talk a little bit more about how that actually works. It was developed at Facebook initially and really as a successor to Hive. If you're familiar with Hive and the Hadoop ecosystem, it's a way to take a SQL query and run initially a set of MapReduce jobs over your data that's in Hadoop, HDFS specifically. It was a good day when the SQL analysts at Facebook could run about 8 queries. And that wasn't good enough for the analysts. They needed to run many hundreds or thousands of queries a day. So they set out to create Presto. And with that, it has proven scalability and high concurrency at Facebook and others that have deployed it, which we'll talk about. One of the interesting things about Presto is this separation of storage and compute. So as I mentioned, Presto is not a database. It's simply a query engine. It queries data that exists in other data sources. So for example, you can issue a SQL query and query data against Hadoop, or you could query it against a relational data source like Postgres or MySQL or Teradata, Oracle, or even non-relational data sources, whether it's Kafka, Cassandra, MongoDB, virtually anything. It really is truly SQL on anything. And the really cool part about this too is you can scale storage and compute independently, right? So take, for example, the cloud use case where data is being stored in S3 or Azure storage or Google Cloud storage at a low cost, and it allows you to bring up Presto on compute nodes and scale to the exact sizes you need. And why this is important is you can scale to the requirements that your queries do, but you're also paying for only what you need. So you no longer have to provision for peak usage. You can provision for optimal usage by auto-scaling out and back. And then finally, as I mentioned, it's really SQL on anything. So the ability to query non-relational databases, relational databases, or even data in your data lake. And there's really no vendor lock-in with Presto. And certainly there's no Hadoop distro vendor lock-in, storage engine lock-in, or even cloud vendor lock-in. What we mean by this is your data is not held hostage by anything. It can be kept in an open format, whether it's ORC or Parquet, and you can keep that in cloud storage or HDFS. But you can also query data that is in vendors lock-in, right? You can query data from Oracle or Teradata or Postgres or MySQL and so on. So it really enables you to query pretty much anywhere in any environment. In terms of well-known Presto users, I'd say a lot of the large web-scale internet companies are using Presto at pretty large scale. This is really just a sample of the customers. There's a lot, users rather, sorry. There's a lot more that aren't on here, but it's just simply a sample of some well-known users of Presto. So we'll talk about the Presto architecture itself. Presto consists of two types of roles when you start up the software, a coordinator and a worker. And because Presto is a distributed system, the system consists of one coordinator and any number of workers. The workers are the muscle that's doing the actual data processing. And the more of them you have, the more processing power you have, the more performant your queries are going to be. You can think of the coordinator as the brain of the system. So the SQL query comes in, it gets parsed, planned, optimized, and it talks to the data sources. In the case of the coordinator, it's getting the metadata from the data sources. So Presto has this connector architecture that allows you to query virtually any data source. And the way this works is via an API. And for example, in the coordinator, it's getting information such as tables, table names, column types, data statistics, anything you might need to plan the particular query. Remember, Presto is just a query engine, so these connectors are responsible for sending the appropriate data to the coordinator. Now, the data itself is sent over the connectors to the workers. So when the workers are talking through the connectors to the data sources, the data is actually being sent over through the workers for data processing. Being a distributed system, the data will be processed in parallel across the workers, in pipeline through, maybe redistributed depending on the complexity of the query, but ultimately the results are sent back to the user. Now the user could have submitted this query via at the command line by writing SQL themselves, or at a tool using JDBC, driver or ODBC driver as well, or any BI tool like Tableau, MicroStrategy, so on and so forth. So there are a number of connectors. Let's talk about a couple of them. So one of the more popular, probably the most well-used connector is the Hive connector. And this allows you to query data not only from HDFS, but also S3, Google Cloud Storage, blob storage, and NS3 compatible storage, such as Minia or Ceph or what have you. The important thing to know about this connector is it's actually not running queries through Hive. If you think of Hive as three things, Hive consists of the metastore, the Hive runtime, as well as the Hive style table format. You can think of it as the format in which the data is stored on HDFS or S3 and what have you. And Presto uses two of those three. It uses the Hive table style format, so it'll read the data. It knows how to read data that's been used by Hive, but also it will use the Hive metastore. It replaces the Hive runtime, and that's where the performance gain comes from. There are relational database connectors as well. These use the relational database JDBC driver to connect to those databases and stream data into Presto for processing. MySQL, Postgres, Redshift, SQL Server. At Starburst, in our enterprise offering, we offer additional connectors such as BigQuery, Oracle, DB2, Teradata. A Snowflake is coming as well. And the really cool thing about this is you can push down some processing into the databases for additional benefit. And finally, we have the non-relational data sources, where there's Cumulo or Cassandra, Kafka, Mongo, et cetera. And the interesting thing here is it's probably straightforward if you think about how you can issue SQL queries to relational data sources or data sources in the Hadoop ecosystem, like on Hive tables, but probably less clear how you might issue a SQL query on Kafka. And really that depends on the implementation of the particular connector. As long as you can take the data and translate it into something of rows, columns, tables that Presto understands, you can query from it. So for example, in the Kafka connector, that's a pub/sub system where you can publish messages to a topic, and then you can read messages from that topic. Well, in the Presto world, Presto will view the topic as a table. It will view a message as a row, and then depending what's in that message, you can parse it into columns. So then you can issue SQL queries against something like Kafka. So I'll talk about Presto and Kubernetes. So we recently announced a Kubernetes integration with Presto. And we do this via what is known as a Kubernetes operator. And this allows you to easily deploy and manage Presto on a Kubernetes cluster. So we have a Presto Docker container as well as the operator to deploy in Kubernetes. And using our Starburst Kubernetes operator, it allows you to deploy to Red Hat OpenShift, Google Kubernetes Engine, Amazon Elastic Container Service for Kubernetes, Azure Kubernetes Service, and Pivotal Kubernetes Service, which would be coming. And it's really cool because now in using the same deployment, you can deploy virtually anywhere, whether it's in any cloud or on-premise as well. So briefly, what is Kubernetes, why Kubernetes, and why is this important? I borrowed this image from Kubernetes.io, the community website, but I think it kind of explains it pretty well, where traditionally you would be deploying your applications on top of an operating system. Often there's contention or inefficient use of resources. So then you have the virtualized deployment that's using VMs better, but you still have sort of the overhead of the hypervisor as well as paying licensing fees for operating systems on each VM. So the container deployment is really interesting. It's really a lightweight, you can think of it as a lightweight VM where there is not the hypervisor or the need to run an operating system, but you're running essentially all the dependencies you need with your application running in Docker containers. And with that, the actual orchestration of these containers becomes, it solves a bunch of problems, but it becomes complex because if you have an application, like these days a lot of microservices, a lot of containers, you need some way to orchestrate this. You could do it with, before Kubernetes, you have to write some scripts or some sort of management layer to manage these containers. So Kubernetes allows you to orchestrate that. So briefly, two concepts. Kubernetes cluster is made up of a bunch of nodes, and adding to the nodes just simply adds compute power, CPU, and memory available to the cluster. You interact with the cluster API, not the nodes, and Kubernetes will handle where your program runs, in this particular case, Presto. So it doesn't run containers, but Kubernetes runs pods, and inside these pods, containers are run. So Presto will be run in a particular pod. So in our solution, pod will have one pod will have a coordinator node, and then you'll have any number of worker nodes. Now, the really cool part about this is because Kubernetes has auto-scaling capabilities through the horizontal pod autoscaler, you can configure our solution to add more Presto workers as needed. So as more demand is put on your Presto system, it can then add more pods into the cluster. And the solutions that are built into AWS, Azure, GCP, or in the public clouds have that also built in to provision additional compute resources as needed. So as you scale pods up, if you need additional compute resources, it'll actually provision those compute resources as well. And then, so this is what the architecture looks like. So we talked about the architecture earlier, where Presto consists of a coordinator and workers. There's a few extra things in our solution that the operator orchestrates. In particular, you'll see that the Presto workers are in pods as well as the coordinator. But we also will run a Hive Metastore service because we're kind of, now you're not really connecting to a Hadoop cluster. You just might be querying data from cloud storage or that you don't necessarily have a Hadoop cluster. So we'll provide that Hive Metastore service for you. So basically as a catalog, so you don't have to connect to an existing Hadoop cluster if you don't want to. And finally, try Starburst. We have enterprise-grade Presto in the cloud and on-premise on the variety of cloud environments. Whether it's AWS, Azure, GCP, on-prem, Kubernetes. And then last, a plug for Starburst is we're hiring here in Boston. So if you're interested, definitely shoot me a mail or talk to me after. We're looking to hire in a variety of areas, such as full stack engineers to work on our web application tier. The Presto core engine, whether it's working on connectors or the cost-based optimizer, working on sort of the auto-scaling capabilities. So we have a lot of really interesting and hard problems that we're looking for good engineers to work on. So I just wanted to put that plug here. And thank you for letting me present. I'll hand it over to whoever next.
Open it up for questions.
Yeah, I can take questions. Yes.
So before issuing
Before issuing a query, you have to create a metastore? Yeah, it's a great question. So let me go back to the architecture here. Oops. So in the case of the data sources like relational data sources or non-relational data sources, Presto isn't a query engine, so it will use the metadata from those data sources, whether it's Teradata or SQL Server or so on. So you don't have to create any metadata itself. We'll actually use that metadata from the data sources. The one exception is when you want to query from HDFS, S3, Google Cloud Storage, Azure Blob Storage. That's because there is no catalog associated with it. It's really just files that have been organized in a standardized format that we know how to recognize. So the way that's the kind of the conventional way that's done is via keeping the metadata information in a Hive Metastore. And this came out of sort of Hadoop in Hive and Hadoop. So the metadata, like where the files exist, what the columns are, what are the column types, that exists in the Hive metastore. So for those data sources, Presto will connect to the Hive metastore to understand that metadata and where to read the data and how to process it. So in order to execute a query for those particular data sources, then yes, you need a Hive metastore. But if you're querying data from, if you're using our Teradata connector, for example, you don't need a Hive metastore for that. You can just get the metadata from Teradata. Does that make sense? Okay, great. Yeah, sure.
Okay, you know the data store and the data sources. So yeah, across data sources.
Yeah, I'm sorry I left that very important piece out today. Yes, that is one of the most powerful things of Presto itself is you can query these different data sources, but in the same query, you can actually federate across different data sources. So that's a very common use case. You might be querying some data in your data lake, wherever it is in HDFS or S3 or what have you, and then maybe you're combining data against some sort of operational store. Maybe it's in Oracle or Teradata. And what you can do is some of the processing will push down to the relational database. You're reading data from S3, for example, and then you can do joins and aggregations in Presto, and it's all done in a distributed way. Yes? Right, that's a great question. So I would say the difference is we can query from multiple data sources. Also, Redshift Spectrum is very specific to AWS. So the ability, you're not locked into AWS. Also, Presto being an open source project, you're sort of at the freedom of that. And really, the cost performance benefit as well. You're going to see a better benefit on Presto. So you definitely you can try that. You can try out Presto in terms of cost savings, but I think you'll see some benefits there as well. Is that a hand raise? It doesn't do result sets. Starburst itself, our enterprise, we do offer Starburst with caching. So it can do that. And what it does, you can cache the actual data at the data sources. So that's really important for, I'd say, the multi-cloud use case, as well as sort of the hybrid use case. So if your data is on HDFS and Presto's on the cloud, keeping the data close to the compute, you're going to see some performance benefits.
What about caching of the metadata?
Yeah, those type of questions, it's connector implementation dependent. So certain connectors do have caching of the metadata, and that's often configurable because sometimes if the metadata is changing quite fast, you have to wait for it to sync. And it really depends on the use case, whether you want to go back to the data source every time or at least cache some snapshot of it. Any more questions? I can take one more. Cool. All right, well, thank you for letting me speak.
Thanks, Matt.
Okay, yep. Hey guys, first I want to thank Starburst for putting together this meetup. This is apparently the first time, this is the first Presto meetup here in Boston. Thanks, Starburst, for that. And, oh, it's not audible. Can you guys hear me? Okay. Okay. Sorry. Yep. Just a little bit about myself. I'm Krishna. I work for Vinay as part of the big data messaging team. As Vinay said, we manage several big data messaging platforms like Kafka, Rabbit, Presto, Apache Storm. So Presto is one of the services that we try and manage, and I had the opportunity to implement and kind of, with the help of our teammates, design Presto here at Wayfair. So I'm just going to talk a little bit about Presto at Wayfair. So our agenda is about like the problem statement, which actually explains like what happened before Presto, like why we want to use Presto, how we kind of ended up deciding that we'll start using Presto, and then quick overview about how our Presto Wayfair, how we have it set up, and talk a little bit about the clients that we use, and also the adoption here at Wayfair for Presto. There's the adoption part kind of compares between how people are using Hive and now how people are using Presto. And also just talk a little bit about like our next steps, like what we are moving towards and what our plans are. And then talk a little bit about monitoring and just open it up for questions. Before I get started, do you guys have any questions? Okay. So one of the main issues before Presto, what we saw was like as a company, Wayfair is growing more and more, and we are hiring more and more people. And as we grow, there's a need for us to enable ad hoc querying so that we can make some good marketing initiatives, or if we want to create new revenues, we want to look at the data, and then we want to see the data scientists, they want to look at the data and then come up with new models and algorithms and see if there's any opportunity to improve our customer service, that kind of things. So ad hoc querying was one of the main issues that we were seeing. Like we had a Hive Hadoop cluster, which was not huge, which was around like 40 nodes, and people were running a lot of ad hoc queries on a daily basis, and that was causing a lot of issues for the batch jobs that was running on our cluster. What happened was the batch jobs, they started to fall behind the SLA. Some of these batch jobs, they run like every hour or every 2 hours, or like overnight jobs. So that was one of the issues. Like people, as we hire more and more people in data scientists and analyst roles, they come in and then they run, some people are really experienced with Hive and some people are not. So they started to run queries like select star from table, and that does like a full table scan. So that's kind of a bad query, and that takes up resources, a lot of resources from Hadoop. Like the vCores goes down and the memory goes down because of that bad queries. So when people start to run a lot of bad queries, the batch job that runs, they don't get enough resources to run. So that was one of the major issues that we saw. And the other one was, you guys might have guessed it, like we had to do a lot of scoop from the SQL servers into Hadoop so that the data scientists and analysts can do some kind of build models on that. So the other issue was the scoop job. We had like a Jenkins job that runs like on a daily basis, and it can take up to like 16 hours. So this was a year ago. So it can take up to 16 hours. And due to the ad hoc querying, it even fell beyond like 24 hours. It even took more than 24 hours. So if you want a table, that if a data scientist requests for a table, and then if he wants to query the table, he has to wait for more than 24 hours before it's in Hadoop to do some modeling. So these are some kind of remedies that we did before we actually researched for anything else. We formed a team to look at all the Hive queries and see if we can optimize those Hive queries, see if we can bring down, say if a query is running for like 8 hours, can we try and bring it down to like 4 hours? So we formed a team and then they did a great job on looking at some of our batch jobs and then try and reduce the execution time or runtime on those jobs. And then we even try and set up some queues so that the ad hoc jobs or ad hoc queries doesn't get a lot of resources, and then the batch job gets all the resources. And then we even try to throttle users to 2 ad hoc queries. So any user, the person cannot run more than 2 queries. And then we even try to move some of our jobs to Spark. We encourage people to rewrite their Hive jobs into Spark jobs. We even tried that. And finally, since Wayfair was hiring a lot of people a year ago, one of the things that helped was conducting some sessions on how to write good queries, how to write like effective queries. So we picked a few people from different teams. We trained them so that when they onboard the freshers, they could actually teach them, hey, these are some of the guidelines before you use Hive. Take a look at these guidelines. Try to see you could follow these guidelines. But still, what we saw is people are still going to run bad queries. They're going to still select star from table. Presto was one of the services that we had in our pocket for a while, and then we never got to it. So a year ago, we decided, okay, it's high time that we get to Presto. So we did a POC, and we tried to get some help from our big data, from our analysts and data scientists, and we figured it was super fast. Like a Hive query that runs for like 5 minutes or 6 minutes was running in a few milliseconds. It was amazing. And then it saved us, even during the POC, what we saw is it saved us a huge number of Hadoop resources. So people who run ad hoc queries in Hive, if it's running faster in Presto, why not just move them over here? So it saved us a lot of resources. And then, unlike before in the slide, I was talking about like us encouraging people to move towards Spark, but there's again a learning curve in Spark. It's a new language; you got to learn it. But again, Presto, it's just a SQL query. Anyone can write a SQL query if you're an analyst or a data scientist. So that was one of the huge advantages for using Presto. And then again, like Matt suggested, you can combine other data sources in Presto. It's more like a one-stop shop for all your data source. So this is a little bit about our Presto at Wayfair. So we follow the mainstream, like how Presto has to be set up. We have a coordinator, and we started out with 50 worker nodes. I think I kind of missed over there. So the Presto clients talk to an Nginx, before the Presto coordinator. So that's how we have our authentication set up. And then Presto can talk to Hive, SQL Server, MEMSQL, and other data sources. We use Puppet as our configuration management to configure all our workers and coordinators. And we use Terraform to build our servers. So this is pretty much our Wayfair cluster. And our Presto cluster is a standalone cluster, which means the worker nodes doesn't run on the Hadoop data node, so they run as a standalone service. We also have a Vertica connector, so that's one of the things that Wayfair did. Wayfair, there's no Vertica connector in the market. Wayfair built a Vertica connector because we use a lot of Vertica. Our data warehouse is basically Vertica. So a lot of people wanted to connect to Vertica. So we built our own connectors, and then we connect that to Vertica. So this is a little bit about like how our servers are set up. We just want to show you guys like how big our worker nodes are. So we have around 300 servers. We started with 50 nodes, and now we have around 300 nodes with one coordinator. Of course, Presto has a single point of failure, which is a coordinator, which is kind of the drawback on the Presto architecture side. So if you want to have HA, it's kind of up to the organization or whoever builds the cluster has to come up with a way to build a HA for Presto. So we currently don't have a HA, and these are, we have around 300 nodes, and each node is about 64 gig memory and 8 cores. So a total of about 20 terabytes. Presto can query, our Presto cluster is super fast and has a lot of memory. And these are some of the clients that we use. We use a lot of dbeaver, we use DataGrip. Some of our data scientists and analysts, they use Python and R to connect to Presto to do some modelings and do some interactive analysis. We also have, Wayfair has built their own a platform, more like a interactive tool, which is called Chronos. We are trying to put Presto together so that we don't have to use any of these, or we don't have to use dbeaver and DataGrip, which is kind of a pain to set up and use with Presto. So if you're looking for, I would suggest, if you want to talk to Presto, I would suggest Superset is one of a cool tool that you guys can use to connect to Presto, because dbeaver and DataGrip are kind of a pain. You gotta at least spend a day to try and get it running. And I just want to talk about how we adopted Presto here at Wayfair. So like I said, we were running a lot of Hive queries before a year ago, and we used to run about like over 100,000 queries in a month, which boils down to 4,000 to 6,000 queries per day. We introduced Presto to production in late January. So since then, we do see a sharp decline in the number of queries that is run in Hive. Even though we see like there are still a bunch of queries that is being run still to this day in Hive. We are actively working on trying to like encourage people to push to Presto. We are still trying to do that.
What's the goal there? Is like goal to like really use some Hive?
So yeah, I'll talk a little bit about that in my later slides. We cannot ask people to completely move over to Presto. Presto is really good for queries which are faster, which are very optimized, which can run within a few minutes. Presto can be used as a batch job, like can be used in a batch job workflow, like which runs for 4 hours or 3 hours. But here at Wayfair, we use it as interactive analysis, like for ad hoc query, which runs within a few minutes. So this is our adoption of Presto at Wayfair. So we introduced Presto late Jan, and then it quickly got picked up in February and in March, and then a decline in April to July. This kind of tells us like when we introduced Presto, a lot of people started using it. We gave exposure to a lot of people, and then they were trying out how Presto works, how cool it is. Hey, I can just run select star, and then it does, even though it does do a full table scan, it's pretty fast in responding. And then we saw a decline, which what we think is happening over there is like people are now comfortable using Presto, and then they are not running like random queries or big queries. They know what they're doing with Presto, and it's kind of leveling. Like the number of queries that runs on a monthly basis, it's kind of it's kind of constant, which means like people, they know what they're doing. And our user community is growing. We started in late Jan. It's about 50 people now. We have about like over 200 people. Our analytics and data science team contains like anywhere between 500 to 800 people or more than that. So, but we are definitely growing. Like we are encouraging people to use Presto, move away from Hive. And there are a few there are a few ways, or there are a few issues with Presto. Like I said, you don't want to run a query which runs for more than like 5 or 10 minutes. If you want to run a query for a longer period of time, what it means is it's going to take up all the memory, it's going to take up all the CPU, hold it until the query completes before it releases. So what it means is if someone runs a huge query, it's going to hold it up, and then it's not going to let anyone run. So which means you're pretty much utilizing the whole cluster. You're not letting anyone run. So we kind of have a throttle. So no user cannot run more than 2 queries, and no user cannot have more than 2 queued queries. And we have execution time set at 5 minutes a few months ago, and after looking at how people are using it, we decided to increase the time limit to 10 minutes. So if you see the mean runtime of our queries, in Presto we run over today the July. I think the number of queries it's not up to date. I think I ran this data a week ago. So we have almost 80,000 queries, and the average runtime is about 51 seconds, which is pretty good. And I collect all this data, which I collected, the number of queries, number of users, and the mean runtime. So there is a connector which is not mentioned in the slides, which is the event listener. You can use event listener to and then configure that to the Presto coordinator, which what it does is whenever a user runs, it kind of captures those events and then log it, and then you can use either you can ship your logs to Elastic, or you can do your thing and then collect all this data. So right now we are moving towards. So currently we use open source Presto, and right now we are moving towards Starburst. One of the reasons is our open source Presto cluster is a read-only cluster. That means no one can write using Presto. You can only run select queries. You cannot run any of the insert or delete queries. So once people started to seeing like how Presto is really useful in their day-to-day life, they wanted to start writing through Presto. They wanted to redo their job, which are running in Hive, redo it using Presto, so that it's much faster. If you run in Hive, if it's running for 4 hours, and if you use Presto, if it's running within 5 minutes, why don't you want to just read your queries? So early Q1, we started to talk to Starburst. We kind of invited Starburst over to Wayfair. We showed our architecture. We talked about, they gave us a lot of suggestions and recommendations, and we tried and include that. So as part of that, moving towards a read-write cluster, we did a POC with the Starburst. So we kind of compared we took about 5 queries, and then we ran it against our open source Presto cluster and then the Starburst cluster. It was pretty good. Starburst cluster was performing better than the open source Presto cluster. It's because the open source, even though they do release every 2 weeks or every 3 weeks, there are a lot of bugs we face. Like some of the bugs are with the UI. If someone runs a very bad query and then you want to go and kill it, the UI doesn't kill the query. So you either have to restart the whole Presto coordinator so that the query gets dropped or the task gets killed. So that's kind of not a good way. Every time when a user runs a bad query, you don't want to restart the whole Presto coordinator, which is not a good way to maintain the cluster. So we came across such bugs in the open source Presto cluster, and Starburst offers a very good distribution. So we kind of did a POC on Starburst, and right now we are using a Starburst distro for our read-write cluster, and then we are doing a POC right now. For the monitoring piece, you guys might have guessed it, I'm wearing a Datadog t-shirt right now. So Wayfair uses Datadog for monitoring. Most of our service checks, host checks, they go to Datadog, and then we use Grafana to pull the metrics out of it. For Datadog, a year ago, they didn't have Presto integration, so we wrote a custom script, which kind of pulls the JMX metrics from the Presto servers and then send it to Datadog, and then we use Grafana to pull the metrics. That's pretty much what we do. Some of the metrics that we care about is the CPU. Since all the workers that we run are VM, so we want to make sure that the underlying hypervisor doesn't get too loaded. If the hypervisors get too loaded, hypervisors are obviously a shared resources. There are other VMs that runs on it, so we get flagged, and we don't want that. So CPU is one of the main resources that we monitor, and the other one is the free memory general pool. This is, again, one of the main Presto metrics that you guys want to monitor. That basically tells us if a query comes in, does it have enough memory to process that query? If this memory goes down, which means the cluster is basically already running a huge query, and it cannot accept any more queries. So right now, I recently checked, Datadog has a custom integration for Presto, so you don't have to write a custom checks. So what's next for us? We want to migrate some of our smaller batch jobs, which are in Hive. We want to convert that into Presto. The other day, I was talking to one of my peers. He was trying to migrate some of the jobs to Presto, and it used to run for 8 hours in Hive, and now it runs within like 8 minutes in Presto, which is like a huge thing. So we want to do that more. And we want to upgrade our open source Presto cluster to Starburst because it's better than the open source. And then also, Wayfair is moving towards GCP. We are expanding our footprint into GCP. So we want to do, once we have all our data in GCP, we want some kind of service that is running in GCP to look at the queries over there. So we can want to do a comparison between Google BigQuery and Presto. So those are kind of our next steps. So questions? Thank you, guys. Yep.
One question. What's the current performance on?
I can probably, if people can hear.
Yeah, give an example of bumping performance from 8 hours to 8 minutes runtime. What's behind this improvement?
So the query that was running, so one of our queries, people run a lot of Hive queries or Hive batch jobs. So we are trying to concentrate on the smaller batch jobs, which are not super important, and even if the SLA goes over, it's okay. So we are trying to pick those kind of jobs from Hive, and then trying to convert that. So since Hive has its own HQL and Presto has ANSYS SQL, we are trying to convert that and try to run it in our Presto cluster and see how it performs. And then we kind of try and do some optimization, like Presto uses CBO, which is cost-based optimization. So we kind of try and juggle the tables, shuffle those tables, and see if we can get better performance. So doing all this optimization, we were able to get it down to like 8 minutes. Yep.
Yeah. You said that you have sub-second queries in Presto. Are you running any real-time traffic against that?
So if you're asking real-time traffic, as in like run against SQL servers, which are like OLTP.
Exactly. OLTP,
Yep.
exactly.
Yeah. So yeah, Presto, like I showed you guys, we do have. So we do talk to Hive and SQL Server. There are a lot of queries, ad hoc queries, which run on Presto, do join tables from SQL Server and then Hive. And right now our execution time limit on all the queries is within 10 minutes. So the queries all run within 10 minutes. So they're pretty fast.
Do you run traffic where you wait for a query to execute in real time? The user can interact with some sort of service and get results, or
If you mean like like customer facing, no, we don't currently do that. Yep.
So when you compare performance, right? Are you really comparing apples to apples? Because the doubt I'm getting is on one side you have probably an overloaded cluster, right? Your Hive and Hadoop cluster, right?
Right.
Other side you set up new cluster, Presto, and you're saying essentially by moving it here, which is not loaded at the same time.
Right. So yeah, of course, with the production cluster, like there's always some workflow or job that is always running. So it cannot be apples to apples. But we did run some tests using. So we took a complex query and we tried to run it in Hive. Since Hive runs a MapReduce behind it, there's always like a I/O. Like it has to write to the disk and then read it from the disk. So there's always going to be a delay or like it's going to execute for a longer period of time. So when we ran the same query in Presto, it was much faster. So I cannot say apples to apples. Our Hadoop worker nodes are pretty beefy. They have a lot of resources. We recently even upgraded, like expanded our cluster. So I would say like the Hadoop cluster are even beefier than the Presto cluster that we have. So even if it's not apple to apples, it's a pretty good comparison. So.
Just one more thing then, right? So at the beginning, you said that you have two problems. One is bad queries, other one is centralizing data.
Yep.
Right? You're using Scoop.
Yeah. So we still do Scoop, but now people don't have to wait until their table is in higher in HDFS, so they can use Presto to actually query the data. They don't have to wait for us to scoop the data and put it into HDFS.
Did you write the MEMC connector, or is that somewhere?
No, we use the MySQL connector for MEMC. Yep. The one problem with that is since we use the open source, some of the MEMSQL tables, they have camel case, and Presto doesn't do a good job. The open source Presto doesn't do a good job on converting that into a lowercase. So when you try to run Presto to connect to MEMSQL, it kind of says table not found, but you do have the table because it's in camel case. That's kind of an issue you see, but I think we don't see that in Starburst. Starburst has like a configuration saying that convert this to lowercase. Yep.
There's a lot of concern that I hear coordinator. A lot of people are concerned about the coordinator being a single point of failure. Would you say in the real world that's a real reliability concern for you guys?
Like I said, we run around 2,000 to 4,000 queries on a daily basis, and every user is restricted to run not more than 2 queries. We haven't seen on a daily basis. We haven't seen like 100 queries running parallelly, even though like there are like 200 people using it. But we did run some tests on Presto. One of our engineers, they ran around 150. They started with 200 queries per second. They wanted to see like how Presto performs. So they did a stress testing, 200 queries per second. The coordinator wasn't acting well. Like the CPU on the coordinator went down to below like 20%, and then once it hits like 10% or something, it just goes offline. It couldn't talk to the workers couldn't talk to any of the coordinators, and then just the VM goes offline. So we have to and then try and restart or reboot the whole VM, get it back, and then it kind of works. So we brought it down to 150 queries per second, and then it was fine. Like it was around like 35%, and it was able to just take all those queries. So we ran around I think 1 million query over the period of 4 to 5 hours.
So in the distributed systems world, you don't want to have a single point of failure. So to answer your question, is there a concern? Yes. I've asked these guys a few times, what are we going to do? You never can have a single point of failure in distributed system, right? We ran some tests, we made ourselves comfortable. Is this still a concern for me? Yes. Yeah. Any other questions?
I have a question for Matt on. So I was looking earlier, it looks like you've got your own SQL parser. Have you ever looked at going to some of the Apache-based, Calcite or any other things, or you can talk about your dialect, as sort of ANSI SQL standard versus other implementations of SQL parsing? Like if we were to bet on Presto big time and put all of our queries in it, is that the one language we should bet on for the next 5 years, your dialect of SQL?
Yeah, so Presto follows the SQL pretty closely.
All 3,000 pages of it, and it's a complicated thing, right?
Right, so there's no database system that follows all. So yes, there are going to be little nuances, but there are no plans. It's very rare that we've found a case where there's some SQL that a tool generates that Presto fix, and when that happens, where you may find challenges with migration of functions. Function names are different across different databases.
Yeah, we've seen this with MEMSQL, although MEMSQL speaks the MySQL wire protocol, it does all the Postgres type data functions.
Idea of function-based Presto, and that will enable his sort of like back in the vertical. Does that exist today? No, but that's the direction it's going. So I'd say if you're going to bet on it, yes, that's the direction.
How does connection pooling works with Presto when it connects to relational databases, relational database servers?
I mean, from what I've seen, Presto doesn't do a good job on connection pooling. So every time it connects to SQL, it builds a connection and then tears it down. So, we have 300 worker nodes, and each worker has a connection to the SQL server and doesn't do a SQL pooling. Like the connection.
And what did we do to get around it? Do we have a dedicated SQL server?
Yeah.
When some if 500 users are using SQL Server, right? Even if you have a dedicated SQL Server, if it doesn't have pooling, I don't think it works very well with any relational database.
I've been through the configuration a few times. I don't see anything close to connection pooling in the SQL connectors.
If I could just add briefly, it really depends on the implementation of the connector itself. So, for example, in the Starburst Oracle connector, but some of the other connectors may not have. But it's a matter of, I wouldn't say it's a limitation of Presto itself per se, but really just so it's something that could be solved.
Any questions, guys?
Okay, I think we're good.
Thank you.
Nice job, Krishna. Thanks, everybody. We will have the video link available hopefully tomorrow. We'll mail it to all of you. So thanks for coming this evening and spending time with us. All right.